Okay, everyone, hello. Welcome to our first breakout session. This is obviously looking at exceptional events and unusual air quality. I'm Angie Dickens. I'm the data scientist with LAGCO, Lake Michigan Air Directors Consortium. I think we have a great panel assembled today here. So I'm going to briefly define exceptional events. I know it may not be something people in the research community think about that much. So EPA defines exceptional events as unusual or naturally occurring events that can affect air quality but are not reasonably controllable. And that not reasonably controllable part is really important. And mostly it's been used for things like wildfires, or sometimes stratospheric intrusions from ozone, some areas dust storms. But the idea is that if you're in an area where your air quality is being seriously affected by, say, a wildfire, the state or local agency can exclude that data from consideration of whether you're attaining a standard or meeting some other requirement. And making that demonstration comes with a huge amount of work, as I think we're going to hear about from people here. And it's been a really big focus for a lot of different air quality agencies. I think I heard like Nevada puts in like 15 or 20 demonstrations a year. I don't know if we can maybe talk about it. There's some of the Western states, they do a lot of these demonstrations. And it can be, yeah, it's gonna be a big focus for time. It can be a big focus for frustration too if EP doesn't approve it and you put in all this time. And I think that also an issue to the bar for approvability has been changing over time or just different administrations. So we're going to hear about that. And the order we're going to go in is a little different than what we have up here. We're going to hear from Arlene Fiore at first, talking about what's a typical event, because with exceptional events, we're talking about what's an unusual event that isn't controllable, outside the range of ordinary. But to define what's outside the range of ordinary, you have to know what ordinary is too. And then we're going to hear from two people looking at what in the Western states about what which is kind of closer to most of the origin of the events. If it's a wildfire, that's mostly out west. And they have more demonstrations out west. And then, but as we all know, that smoke, for example, can be transported east, and it does impact us out in the eastern US here as well. So Michael Geigert in Connecticut is going to talk about kind of transported events. And then we're going to kind of shift gears a little bit at the end and look at modeling for regulatory purposes. So I'm going to start off by introducing Arlene, who's our first speaker. Arlene is a HAQAST member. And she's going to talk also about her project, which is looking at spatiotemporal patterns and the nexus of air pollution, climate, and public health over the northeast US. She is the Peter H. Stone and Paola Maldonado Stone Professor of Earth, Atmospheric, and Planetary Science at MIT. As I said, she's going to talk about characterizing typical pollution exposures and events.
So right, my title was my attempt to fit into the exceptional event session when our core work is really more on that local to regional scale, and also working kind of with the health community to come up with best estimates of exposure for PM 2.5, ozone, and NO2. And so these are just highlights from a graduate student, Madangui Tao, who's here at this meeting. She has a poster tonight on ozone, and then with my co-I, Mariathi Kirmotsoglu, who's in the Columbia School of Public Health. Her student, Sebastian Rowland, has a paper in prep describing a new product that is now available. That's an ensemble product that I'll briefly introduce here. So I thought I would, I'm not clicking. Oh, there it is. It's just okay. So I thought I would use this figure from a recent, 2 years old now, but environmental manager article that Terry Keating at US EPA actually put together from some old model simulations that a former postdoc of mine had run with the CAMx model, and a student analyzed them from the perspective of background ozone published back in 2018. And what I really like about this figure is it is attempting to contrast the eastern US and sort of the different sources of ozone that contribute to what the total measured ozone is, and the Intermountain West on the right-hand side. And so I think in this session, we're going to hear about the different needs and some of the same challenges faced by Eastern US and Western US air managers. And when Terry Keating talks through this, what he points out, sorry, I'm clicking the wrong way. You're fine. there we go, is that we really need to understand quantitatively what these different contributions are to total ozone, because they're handled under different parts of the Clean Air Act from a regulatory perspective. And of course, our focus today is on this light blue. USBO is US background ozone. And the way we did these model simulations, we didn't directly track the fires or stratospheric components, so those are just sort of lumped together in this blue estimate. And I should emphasize that these are 9-year averages of summertime daily max 8 hours. So this is kind of intended more as a schematic of sort of what's maybe typical, at least according to this particular model. So I'm going to focus in or try to, oh, sorry that the words are a little bit cut off, but some things that came to mind as I was preparing this talk were in part motivated by discussions over the years, including with Gail Thompson at US EPA Region 8. So I wanted to mention that she's often bringing up, you know, in order to define exceptional, we need to understand routine. So I didn't want to steal her words, so I used typical. But the other aspect that I've gotten really interested in thinking about through conversations with many of you over the years is the idea of also when we're thinking about these individual components, and start to think more about the health impacts, what are the co-exposures? And so for instance, when a wildfire event is happening, we might expect that the ozone portion is also coming along with PM, which might have a very different health impact than a stratospheric ozone intrusion, for instance, where other than the ozone, it's very clean air. So these are questions that certainly I'd be interested in exploring if people are interested. So to move into our updates from our core project, what I'm showing you here is this work from our collaborators at the Mailman School of Public Health. This is basically 7 individual PM 2.5 products were taken together into the statistical framework called Bayesian Non-Parametric Ensemble. I don't have time to go into the details here, but basically the idea is that we know that we have differences across different data sets for PM 2.5. I'll just note, since Randall's sitting in the second row, that one of his group is one of the products going into this. There's also statistical approaches, there's modeling approaches. But the idea is you put all this in on equal footing in this statistical framework, and can also assess uncertainty, where the uncertainty is defined as the difference across the individual products combined with differences with the AQS monitors that are taken to be the ground truth. Now, one of the issues is that several of these input data sets use the AQS monitors to develop the data set. So there's some circularity here, and it's not really that clear how to get around that other than to find independent data sets to evaluate with. So that's my sort of piece in this project, was helping define input data sets and also the external validation. So I should mention that this work was funded through NIH, a grant to Marianne Viana, Kim Wurtzeblu. You can also, of course, look at regional trends over time. This is a 6-year product that Sebastian's developed here. And so for our HAQAST work, we're now working on regionally optimizing this for the Northeast US for use in epidemiological analyses. We're also going to apply it to 2019 NO2 data sets as part of Dan Goldberg's Urban Knox Tiger team. I also wanted to highlight, now switching to ozone, this was the work, if you were at the last session that I referred to, my student Madonkwi Tao just published, I think came out last week in Environmental Science and Technology, using the Long Island Sound tropospheric ozone study, field campaign data, tropomi, and the graphical abstract here kind of illustrates the key findings that on high ozone days, these data sets indicate that formaldehyde is going up, NO2 is increasing, but overall the formaldehyde to NO2 ratio goes up, suggesting that formaldehyde kind of wins out. And this is what we see when we use Laura Judd and Scott Jans's GCAST Tasso retrievals. This is at 0.01, so roughly 1 kilometer, regridded to approximately 5 kilometers by 5 kilometers, and the tropomi data gridded onto a similar grid. And so what we see now is compositing over non-exceedance days versus exceedance days. We see kind of the yellows and browns expanding over spatial area on the exceedance days, suggesting that more of the region is moving up on this. So in other words, that the highest ozone days are showing a potentially stronger efficacy for NOx emission control. I do want to mention she has a poster on different work, also using the Listos data as sort of a pre-tempo analysis to look at diurnal cycles and formaldehyde and NO2. And so I encourage you to check that out tonight. I wanted to show you the NOx or NO2 changes that she diagnoses on the non-exceedance days versus exceedance days. Again, using on the over here, the airborne data regridded to the same grid as Trovomi and Trovomi here. That is supported, the increases in NO2 in the New York City metropolitan area is supported by higher tropospheric NO2 retrieved from the Pandora spectrometers in the New York City and downwind regions. That's what you're seeing is the percentage increases on exceedance versus non-exceedance days. We also, of course, have the continuous emission monitoring systems measuring what's coming out of electricity generating unit smokestacks. And we see that those emissions are also higher on exceedance versus non-exceedance days, suggesting that within region, there's opportunity to reduce NOx and potentially also reduce ozone based on the findings from this study. This slide is put together by Sally Prusetta, who's at UVA, and I wanted to just highlight her work because I think it's really relevant for our community. Her student, Isabella Dressel, just also had a paper, I think come out last week or the week before, in environmental science and technology, showing, really evaluating the utility of daily Trovomi satellite observations to diagnose inequalities in the Newark and New York City urban areas. And they're able to do that, again, because of the Listos data where Laura Judd's NO2 instrument was flying. And so they can really evaluate whether they can get the information they need at the scales that Trovomi can retrieve at. And overall, the answer is yes, actually, for census, looking at different census tracts, the way the different populations are distributed in this urban area, Trovomi is seeing the NO2 inequalities that are retrieved from the higher resolution airborne sensors. But you do need to make sure to have enough coverage of your urban area. So in other words, there can't be too many cloudy days or you won't be able to diagnose the neighborhood relevant inequities here. Okay, in the interest of time, I'll just quickly highlight that there is this systematic overburdening of communities of color and low-income neighborhoods. But she also finds that there's ozone co-benefits that would be associated with reducing these NO2 inequalities, and that there's indications based on temperature and heat that the inequalities could worsen, the burden faced by these communities could increase with climate change. Okay, so to sum up, I did want to note that my student, Madame Kui Tao, her current work is moving towards being relevant for this session. So I wanted to advertise where we think we're heading at a time when we can get input from all of you in the air quality management and health communities to see whether there are things we can tweak to make the work most relevant. So during summer 2018, you may not remember back that far because there's been fires almost every summer in the Western US that have reached the Eastern US, but it happened in 2018 as well, when we have these field campaigns. And so the question that Tama wants to look at is based on conversations with Michael Geigert, how much is smoke impacting air quality, both PM and ozone, in the Northeast region? And of course, we know that the Western US faces a bigger impact from these as well. And so we can take advantage of field campaigns, one focused on fires during that summer, we can, in addition to Listos and satellite data. And we're excited to test out using a fairly new tool in the atmospheric chemistry modeling community that allows for variable resolution gridding, where we can nest down over the source region and the receptor region. This is with the Musica model developed at NCAR. There's some initial papers out. And what Tama has done is to take information from Michael Geigert, where he identified days in summer 2018 that may be impacted by smoke, line that up with what she's done to identify where are all the high ozone exceedance days during this period. And so these red or brownish color boxes are where we'll probably focus our analysis first. And so I'll wrap up there. I think I'm out of time, but just come back to saying that I think there are really looking forward to the discussion and the other panelists' talks. And if there are ways that we can help out with thinking more about typical versus exceptional, and from the health perspective, thinking about co-exposures from some of these different sources contributing to ozone, I would love to talk with you. Thanks. Geigert.
Yeah, okay. Thanks so much, Arlene. So we're going to hear next from Jay Baker, who is the Senior Policy Analyst at the Western States Air Resources Council, or WESTAR, based in Utah. And Jay helps coordinate regional exceptional events issues for the Western states, and there are a lot of them. So I think this keeps him very busy. And he's going to talk about identifying exceptional events and creating demonstrations.
Right, thank you. And surprising, I'm glad you mentioned the number, and also, Angie, thank you for mentioning what an exceptional event is, because that's, let's see if this is going to work. There we are. It is going to work for me. I'm going to start off, I'm going to keep myself very general. Like I said, like she said, I work for WESTAR, 15 Western states and air agencies within that area as well. And so I'm going to stay general, but I'm glad you mentioned the definition of exceptional events, because we could talk about what's exceptional and what's an event. You know, when a wildfire lasts 3 months, is that now an event or not? So, but in this context, I wanted to stick, like you said, to the statute, to the regulations that are out there. And you already mentioned, first of all, it's an unusual or a natural event, and there has to be clear causal relationship between that event and the monitored exceeding that we saw. So the second part of this is it has to be not really reasonably controlled or preventable, which is another thing to prove. But and third, it has to cause an exceedance or lead to a violation of the National Ambient Air Quality Standard. And that's probably the highest hurdle when people are putting these demonstrations together to prove. We call it regulatory significance. Well, that along with the exceptional side of things, I guess. But lastly, probably most importantly, when states submit these or agencies submit these, the administrator, the EPA administrator has to say, I concur, that's an exceptional event. Otherwise, technically, it wasn't an exceptional event. And these are all examples of exceptional events that are identified in the rule as being. So we've got dust storms, volcanoes, prescribed and wildfires, both, even fireworks. I don't have stratospheric intrusions up there, but those are included. Let's see, it's not going to the next slide. There we go. But just to give you an idea, and I think others are going to talk a little bit about this, but when we talk about wildfires in the West, those are the big exceptional events. And it's partly because if you look over the past so many years since 1985, oddly, that top darker blue line shows that wildfires, the number of wildfires has actually decreased slightly. The trend is decreasing, but the size of those is increasing by quite a lot, by much more. I wouldn't expect the decreasing number of them to continue. I think that's just maybe noise in the data. But I will note, you can see there in 2016, the exceptional event rule was revised in 2016. And while we expected, or EPA may have expected to see this flood of exceptional event demonstrations come in, they haven't. There have been a fair number, but they see maybe 20 a year, oddly enough. So it seems like, sounds like there are a lot, there are potential to be a lot. I'm going to show you that in another slide, that there's the potential to be a lot of exceptional event demonstrations. Just to give another data point with the wildfires in 2021, which was, like Arlene mentioned, 2018 was a big year. 21 was also a big year. About 20% of the monitor days in the West were impacted by a wildfire event. That doesn't mean they all exceeded the standard on those days, but they were impacted as identified by the agencies. So when we're thinking of an exceptional event, agencies have to sort of consider first some short-term issues and then some longer-term issues. And I'll talk a little bit about the short-term. So the first of all, even within these, they have to be able to forecast so that they can let the public know this is going to happen, whether it's a dust storm or a fire or a stratospheric intrusion, whatever it is, they've got to be able to say, this is coming, you need to be prepared. And by and large, agencies are fairly good at this, some much better than others. For example, Arizona gives hourly forecasts in the Phoenix area for their air quality. And But anyway, so the second part of it though is once they can forecast and say things are going to happen, there's going to be a poor air quality in your area, they need to notify the public, because that's the most important part, I think, is making sure that the public understands something's going, that the air quality is going to be bad and what they should do to protect themselves from it. And so, agencies use blogs, websites, social media, apps, news, pretty much everything that you can think of to do that. This is a blog from Oregon. And they do, again, it's hard to say how well of a job that they do. I mean, they use every tool available, but it doesn't always reach every audience, I think. But once you get past the event, the actual event, and making sure people were safe during that exceedance, the next thing the agencies have to consider is what do they do with the monitoring data that they now have. It maybe shows an exceedance of the standard. So the first thing they can do is flag it. And there are different types of flags in the air quality data. For example, the orange that you see in these bars, and this is just in the RAP region, this slide in 2021, and just for wildfires. They can flag those and say, there was something that happened at the monitor. We think it was because of smoke in this case, but we're not asking EPA to take any action on that. So quite a few that you see in 2021. The other type of flag they can do is what we call an exclusion request, and that's in the blue there. So there are about 2,000 between those three pollutants from 2021, where they can say this affected the monitor, this wildfire, and we may submit an exceptional event demonstration on that. But like I said, it's not always 2,000 of them that go, and we'll talk a little bit about why that is in a second. But so at least EPA now knows, okay, there's a potential that we're going to have a demonstration because of this monitored exceedance. And just as a point of reference to comparing the east and west, or the west to the rest of the country, these are the flagged days for the west. These are those flagged for the entire country, and you can see that the exclusion requests only went up by, I think, 20, roughly 20 or 30. So there is a big Western issue. So again, the long term, so now we've got past flagging and notifying. There's a long term question that agencies have to answer. Regulatory significance is the main one. So for example, as the CASAC considers a new PM standard right now, if that changes next year, let's say they propose a change to that, states will need to go back to their data, and that's a 3-year, the NAAQS will be based usually on a 3-year average. So that means they're going to have to go back 3 years and look through all of those days that they flagged and say which one of these contributed to our exceedances, or contributed to our potential non-attainment of this new standard, and which of these do we now have to prepare an exceptional event demonstration for. And so it's tough to, even though you flagged it, it's tough to go back, and that creates an issue with finding the data. Data doesn't last for 3 years in a lot of cases. You may find news stories, but even satellite data, there's no repository where I can say I need to go back to May 11th, 2018 to see what the air quality looked like in these satellites. And so that's really a huge need that we've heard from the agencies that we work with, is how can we easily go back and find that data? Sometimes it is there, but it's not easy to find. And of course, because it's not easy, there are staffing concerns. Somebody mentioned it. Oh, somebody mentioned it earlier today in the 4 session that low on staff. State agencies are facing the same problem, and so we don't have often the resources, the people to go back and find those. And the last part is the complexity of these demonstrations. It may seem straightforward, but determining a clear causal relationship, like Arlene said, saying this is what was normal and this is what's exceptional now, especially if the fire season, for example, lasts 6 months. Normal is different now. And so it's very complex. And just to give you an example of the complexity, this is a real quick, an exceptional event demonstration from Coastal Junction in California. And so they used a satellite image to show that the fires were, the smoke from the fires was coming to the monitor. They used an image there, a picture from a webcam that they have at their monitoring site to show the smoke is actually there and it's bad. And you would think in some cases, well, you know, it hit 189 micrograms per cubic meter of their PM10 monitor. That was the 24-hour average. You think that'd be a pretty straightforward exceptional event demonstration. So they went on for another 100 pages to prove how that actually was an exceptional event. And if you'll notice, the day after that, I have in this table, that same monitor hit 553 micrograms per cubic meter for the 24-hour average. And that was because the smoke still was there and they had a huge dust storm that rolled in. I'm gonna say, well, that seems pretty clear cut. They didn't submit an exceptional event demonstration for that one because it was too complicated because of the two events at the same time. So you start to understand that this isn't just a straightforward, yep, here's the data, and we're good to go. Sometimes it becomes very complex. So some of the things that we're doing at Westar and the Western Regional Air Partnership REP, trying to address some of the regional needs, which we've identified through some surveys that we've done. And most of them are some of what Arlene just talked about, helping to understand the typical and also helping to understand how many emissions come from that particular event. Those are sort of the first two boxes, and then trying to figure out again, how can we store this data so that it's easy to find 2 or 3 years later. And then finally some training. Looks like I'm about out of time, but this is one module we are working on with the South Coast, partnering with South Coast Air Quality Management District to help at least streamline how quickly it is to how quickly we can put together some of the information once we need to. So I think with that, maybe not questions, maybe we save those for the panel. So I'll turn it to the next person.
Great.
Thank you.
We will hold all questions to the end and we'll have them up, but we should have some 25 minutes or so for discussion at the end. Next speaker is Janice Snyder, who's the program manager at the Sacramento Metro Air Quality Management District. She was the lead staff person for Sacramento's successful exceptional events demonstration, which I believe is the first in the nation for ozone from Wildfire. So we'll hear lots about I think exceptional events in California from Janice, and great to the title.
Thank you. Well, thanks for having me here. She mentioned, I work at a regulatory agency that is responsible for making sure we meet the health standards in our region, and we have. Oh, okay, so just to give us a little bit of a spatial scale, I'm in Sacramento over in the West Coast. California is made up of 35 air districts. And our county is the one here on the right. And that's what our air district is responsible for. I just put the little dots here, which is our regulatory air monitoring network. And in our region, we are currently non-attainment for both ozone and PM 2.5. We have reached attainment for PM 2.5, but we haven't been officially designated as attainment because you have to put together a whole a demonstration of plan on redesignating. And you can see that, this is Sacramento County here, but then it also spans several other air districts that we work and partner with when there is on-state implementation plans, which includes demonstrations for exceptional events. You can go to the next slide.
Okay.
So like I think everybody knows, there is annually California suffers from wildfires. And in the past, decade, it seems to have increased, and that's because, climate change, due to climate change and smoke from these wildfires are really impacting our ability to show attainment to the EPA in terms of reaching federal health air quality standards. And evidence and EPA, like Jay has discussed, has a mechanism for us to exclude that data from these determinations, but it requires, because these have a lot of legal implications and lots of people are watching, they need a substantial amount of evidence to demonstrate that it was really because of the fires and not just because that it was really because of the fires and that they were really not controllable by the agency. Okay. And Sacramento has successfully demonstrated two, and that doesn't necessarily mean we, over the past decade, we have only seen wildfire impacts from wildfires 2 times. It just means we only pursued 2, and Jay was really doing a good job in emphasizing why that is, and that's because agencies are most likely going to only pursue exceptional event requests if they have a regulatory impact. And because of and that's because of the intensive resources that it takes to demonstrate a clear causal relationship between that specific event and the violation. So one of them was, the first one was for the 2008 wildfires. There was over 100 wildfires going on during that time. And I wrote old rule and new rule on here because that made a difference. It was very difficult before the new rule. It was still hard with the new rule, but it was very difficult under the old guidance of getting this approved. And so it was almost like a 2-year process. I think we started in 2009 and EPA approved it in 2011. And I think we spent over, I want to say like $100,000 doing all these different types of modeling, staff time to actually get it concurred. And that was important because we had a 1-hour attainment plan that we needed to submit to the EPA to demonstrate that we could meet that particular standard. And that's also important because if we don't meet standards, then there could be transportation dollars, businesses could be fined. And so it's important for us to be able to show that they weren't controllable by us, but of an external event. The second one that I have is a PM10 exceedance. And that was from the 2018 fires. And the reason why we pursued that one is because we had a second maintenance plan for a PM10 standard. And so therefore, we needed to do that particular exceptional event to show that we actually were able to maintain the PM10 standard during that time. So ultimately, what counts as an exceptional event, and ultimately it's what EPA can concur with after considering a weight of evidence of why an event is not reasonably controllable and not reasonably preventable by an air quality management agency. And as I shared earlier, we are a regulatory agency that develops rules on stationary sources. The state is responsible for mobile sources. Again, do we have any of those controls that could have prevented this event? And I just checked the EPA website not too long ago, and under the new rule, and a majority of the exceptional events have been impacts from wildfires or high wind events. And climate change is going to continue to result in a growing need of this demonstration, not just in California, but as Jake was saying, from California all the way to the East Coast, because there will be impacts. I'll say that wildfire impacts on PM are more straightforward for us here in California to prove than impacts on ozone. And that's because, it's a, direct emissions. And so there's a lot more evidence, I think, to be able to prove that causal relationship, especially when wildfires are during, when our normal, typical exceedances are not during that season. And so wildfires occur, during the summer season, while in Sacramento region, we typically see higher PM concentrations during the winter time. And that's due to wood burning. Majority of it is due to wood burning. And so this is kind of how I see an exceptional event relations. Like here's the middle, is like, okay, is it worth our time? Is there a regulatory significance? Is it, can we make a causal relationship? We look at transport, we look at historical trends, and we look at both the direct and precursor emissions, as well as the definition of what is natural and uncontrollable. So we see the challenges, this is going back to the 2008 wildfire impact on ozone. And like I mentioned, the challenges right now, especially as ozone standards are, CMAQ standards are decreasing, Sacramento, has a summertime ozone problem that's exacerbated by wildfire. And it's really difficult to make that one-to-one correlation, even with modeling, even with ground-based measurements. But for the 2008 wildfires, we used satellite information from the OMI satellite data that showed tropospheric NO2 data compared with ground-based measurements. And so we were able to take a day that we considered a surrogate day. That basically means that the meteorological conditions, the emissions were all, supposed to be similar. That where it's like our control day, and we compared that to what we saw on the exceptional event days. And so you could see here on the control days, you don't see much NO2, not none in for the ground-based measurements, but during the exceptional event from the satellite data compared with the monitoring data, you could see that there is a clear impact. So this is my last slide. Satellite data, I think we've heard from the earlier panel that it's not yet a replacement for regulatory ground-based measurements, but they are used to make regulatory decisions. And so, for example, removing data from regulatory use to determine whether or not we are in attainment or not. It can show spatial scale of the event and fills in the air quality gaps for a convincing story to the EPA. And so we've used fire and smoke map, we use direct and precursor emission maps. And my last question here is to pose to you all, the academics, and are there other resources, assets, tools that HAQAST can really help us streamline this demonstration so that we can, use less resources in proving these exceptional events than to do some of our other regulatory work. But that's my contact information. Answer any questions?
Great. Our next speaker is Michael Geigert. We're going to move east, downwind, and look at what happens when wildfire smoke is transported across the country. Michael is an air quality meteorologist at the Connecticut Department of Energy and Environmental Protection. He's a HAQAST ambassador, so one of the super users. And he does air quality forecasting analysis, draft SIPs, maps emissions and uses satellite images and data to track wildfire smoke plumes.
Hey, thank you for glorious introduction. By the way, Rachel, I do have a couple animations. They don't run. You might have to mouse it to run.
Okay.
But anyway, definition, well, Ray went, fortunately, went through this, right? Jay?
Yeah.
So, basically, we do have the definition and causal relationship. I mean, have you heard that before? Yes. Well, that's probably the hardest thing because you think it's simple, right? A equals to B, but however, that ends up being the crux of the matter. And they say stagnation of air masses, meteorological inversions do not directly cause pollution emissions. They're not exceptional events. But of course, I put in there, they will exacerbate. You get smoke, high pressure, it'll make it worse, but it is not the cause. And of course, meteorological events, just because it was hot and dry summer, it's not an exceptional event, but it'll nurture wildfires and also dust. So obviously you can't blame it on that. That's going to be an issue. And of course, you have to notify them. Jay mentioned the informational flag. I encourage everyone to use those because those are free of charge. Don't cost anything. If you think, they go away. They can only use an R flag to concur. So just a thought. And even if you use an R flag, it probably wouldn't be much of an issue. Forward arrow should work on this, or
That should work.
okay, there you go. Okay, and there's the rule. He went into that. You go through a narrative. I mean, these things are lengthy, right? I mean, I don't think ours is probably on under 100 pages, but still, I mean, it was a lot because you have to do images and you have to do the narrative. The narrative is incredible. So they recommend, I saw this, should be at least 5 to 10 ppbs higher than non-event because you have to compare it to the non-event date. Of course, you can say, well, this is what you would expect in this kind of date, but some areas like South Coast, probably like Long Island Sound and Chicago area, you might have an ozone event anyway that day because you always do if you have a sea breeze. And so you have to somehow convince EPA that it was worse, it was exceptional. So that's interesting. I mean, the rest of it is relatively straightforward. It wasn't reasonably controllable. We know that. Wildfires, unlikely reoccur, etc. Public comment, easy. Okay, let's see what we got here. And they make a checklist. Make sure you have your checklist because you have to have everything in order here. Characteristics, you have to do the conceptual model. And of course, if you've done this before, you'll realize that you have your own templates. Westar sounds like they're doing their templates, so it will make it easier. So you will, but the regulatory significance, we'll go into that in a minute because you're not going to do this. That's one of the first things we look at. Is it going to make a difference? Because it's a complete waste of time. It's not going to make a difference. It might make you feel better, but it won't make a difference. Okay, so and like I said, the non-event conceptual model. But I put, what about enhancement? We get a lot of smoke from the west and the southeast. Amber will talk about that too. The ag fires, the wildland fires down in the southeast states, constant plumes, especially early in the year. You'll see the smoke. And we'll talk about the Illinois incident in a little while. So pick a tier. I used to call it Trail of Tears, but it's because they want you to pick a tier, right? And they talked about this before. It's kind of arbitrary. We thought, oh, it'd be easy. Well, let's do tier 2. They're higher, and but if it's so far away, EPA came up with this amazing little tier system. They do Q over D. I thought it was sort of a waste of time. You do the emissions per day, tons per day, right, over kilometers away. So in their one of QA's documents, they had little circles they produced. I put a little red circle around the Flint Hills. I mean, they can burn 1 million acres there. They're a lot, right? And 100, what they say is Q over D. If you have if the ratio is 100, then you can use tier 2. Your tier 2 is a little less work, supposedly. You still have to do a causal relationship, but see the little circles I put there. Huge fires. I estimated if you're about 500 kilometers away from the Flint Hills, maybe you could use tier 2, but most areas probably are much further away. And what did we do? I'll mention a little bit about what we did. Fort McMurray, of course, that was our big thing because anything that happens east of the Rockies affects the East Coast more because they're lower level smoke. The smoke doesn't have to go over the Rockies. We get a lot of smoke from the western wildfires, but they tend to stay high, about 10,000 feet. This smoke, for instance, and I'll mention the other smoke too, another event, tends to stay closer to the ground. It gets injected, but it can come down to the ground much easier. So, oh, see, there you go. It did work. See this? Not everything's an exceptional event. But look at this. This is one of our monitors. We didn't know this was happening. So is this an exceptional event? Right. You can see the ozone levels of the 300-400. Well, it's not an exceptional event because wildfires don't produce ozone that quickly, right? We put it down as equipment malfunction. It went down to -50. So basically, I thought this was interesting to show because ozone does get produced, but not right away. It does take days. They say 5 days sometimes. I mean, sometimes you get so much smoke interaction, that's just not enough sunlight to produce the ozone, right? But that was an interesting event because nobody told us they're going to have a fire right next to our ozone monitor. So, of course, out west, some of your ozone monitors actually get burned in the fires. So it's like a little different. That's a malfunction. Regulatory significance. Well, we at the time see. Every monitor in Connecticut was affected, but we had to choose. Region 1 said you can't have it all, right? You can't have it all. So look at our design values. They haven't gone down much. Our highest, this is 2016, remember. 2022, our design value at Westport's 81 still. So we're not going down very quickly. But we went from 85, which the old standard was 84. We didn't want it to be 85. Take it out to 83. Cornwall's our high altitude site. We thought, we didn't want to get it close to 75, so we took those monitors out. But Abington's actually where I live, northeast Connecticut. It was getting close to 70. So we were selective. We chose these monitors. We thought that was good, but it was still an uphill battle. So here's the satellite stuff. So slam dunk. See, there it is. There's the ALD, came over the Midwest, high pressure, sat on it. It came down from the Lake Huron area and affected us. That was pretty convincing, right? I mean, there was a fire, Fort McMurray, there was the plume. And so, satellite data is sort of the, if you didn't see anything like this, maybe you would not think it was the smoke. Of course, satellite data does need to see the smoke, so you can't have too many clouds. We also have ceilometer backscatter. And I'll show you in a minute. Illinois did a thing, and they have backscatter. They have smoke. You don't have to have smoke. Look at this at 2,500 meters, 2,000. Smoke, East Coast generally in the boundary layer, 2,000 meters about it. So you can see, I mean, you might not say it's a lot of backscatter, but it was enough. So there it is. There's the trajectory analysis you need to do. Pretty close, right? And you do a similar day analysis. We did this. I didn't do surface winds because surface winds along Long Island Sound are always a sea breeze. I always get a southwest wind just about all the time. So I did 850 trajectories. You can see them. Good days, good days. Look at that. Bad day. New York State, never like that. And they want you to do percentiles. Well, they weren't quite 99, but it does kind of help. What about PM 2.5? Now, 2021. Big year, right? Look at that. Look at that. That's PM. Yeah, that could be an exceptional event. But was it exceptional? We had some really high numbers. I mean, those are 24-hour averages. 1 hour averages well over 100, right? So we were definitely experiencing it. But you have to have 98 percentile for everyday data, 8 days. We only had 2. We didn't flag it because what difference would it make? It affected people's health, but it would have been exceptional. But here's Minnesota, closer to the fire. I did this for Minnesota. Look at that, how many days they had. It was their maximum. If it went down to 30, they have a lot more. So I would hope Minnesota was maybe considering flagging these. And here's the one for the Chicago event. I mean, yeah. And you can see these were the forward trajectories EPA did. That said, that wasn't quite affecting them. HMS smoke, look at that smoke. It's showing smoke, just not from the Arizona fires. But Look at that area of moderate ozone all the way from the southeast fires. They were definitely affected by fires. I'd say 5 to 10 ppbs. Entire area. So anyway, aerosol watch, you go there, look at that smoke. See, I took that. You can see a smoke plume, right? Those days. EPA said there was no smoke. They took Veers or Modus, whatever. Said no smoke. Go early in today, there was smoke. Non-concurrence, not sufficient, no transport, not sufficient. But that's another day. Okay, so anyway, I've just pointed that out. There's just a lot of smoke. A lot of smoke, and it's continuous a lot of times. Is it exceptional? We call it enhancement. So we just have to go with the flow. If it's going to affect our design values, we'll flag it. That's my advice to you. And if Minnesota's out there, then I consider those days from last year. Okay.
Okay, great, thanks so much. Our last speaker is Jeongran Yun, sorry, who's a research scientist at the New York Department of Environmental Conservation. She does photochemical modeling and analysis to support state implementation plans, and she's going to shift us a little bit. We're going to look more at regulatory modeling.
Thank you. Thank you for the opportunity to present our work in this meeting. And I'd like to thank my colleague, Yuan, Winston, Eric, and Kevin. And we perform CMAQ and CAMx air quality model and analyze data. And here, the air quality models are used to simulate for both the base year and future year air quality for modeled attainment tests. And modeled estimates are used in a relative sense to project the future design values to determine whether attainment will be reachable or not. And by comparing to the ozone max. So in this presentation, we compared modeling performances between CMAQ and CAMx and 2016 version 1 and version 2.3 emissions platforms. And we compared the modeled outputs to satellite products. And we also compared the preliminary 2023 projected ozone design values. And this table shows a list of modeling we compared in this presentation. And version 2016 version 1 was developed as a collaborative effort between EPA and state and NGOs. And 2016 version 2.3 is mainly updates from EPA mostly. And future years were projected to address non-attainment issues. And CMAQ version 5.3.1 and 5.3.3 are comparable in terms of ozone prediction, because 5.3.3 is just a minor update to the previous version. And for CAMx version 7.2, there are new features. So we used that new feature, new vertical advection option for that. So this animation shows hourly difference in NOx emissions between those two platforms, version 1 and version 2.3, over our 12-kilometer domain. And warm color indicates NOx increase from version 1 to version 2.3, and cool color indicates decrease. And as you can see, the differences vary over the region. And the largest changes in NOx emissions were from on-node sources due to changes from MOVES 2014 to MOVES 3 model. And this shows a spatial pattern of a normalized mean bias of maximum daily 8-hour ozone with a 60 ppb threshold from May to September using version 1. And on the left, CMAQ, and on the right, and CAMx results. And as you can see, CAMx predicts a higher ozone compared to CMAQ with more warm colors. And this just shows comparison. The model performance and using version 2 and 3 platform. And again, CAMx on the right shows one color and predicts a higher ozone compared to CMAQ on the left. And this is version 1 and this is version 2, 3. So when you see the colors and using version 2, 3, shows a little bit of true color, indicating using version 2, 3, ozone predictions are lower. And this shows normalized mean bias using version 2, 3, using two different CAMx versions, version 7.10 on the left and CAMx version 7.20 on the right. As you can see, they show a similar performance. And this shows comparisons of MDA ozone by month and by US climate region. And as you can see, early months in May and June, model tends to underpredict, way lower than the observations in gray color. And overall, and blue color shows lower ozone compared to the red color, which is version 1 platform. And this is using CMAQ, and this is another way to show those performance. And this shows ozone diurnal patterns by US climate regions and overall over May to September period. So as you can see, on average, the models underpredict ozone and for all regions. And red using version 1 compared to blue using version 2, 3. So except this region, Southeast, and other regions on average, version 2, 3 shows lower ozone prediction. And this is using a CAMx model. And here, red color using version 1 platform, and blue and orange using version 2, 3, but two different CAMx versions. But those using version 2, 3 and two different CAMx versions, they show similar performance compared to the version 1, like in red color. So also for CAMx using version 2, 3, ozone predicted lower comparing to using version 1. And this shows ozone diurnal patterns and similar results. But for Northeast and Southeast, this CAMx performed better on average. And this shows tropospheric column NO2 comparisons between model outputs and OMI products in July 2016. And using the model outputs are based on version 2, 3. And overall in this area, model NO2 predictions are lower compared to the OMI data. But when you look at the new city metro area, model predicts NO2 higher compared to the observations only. And now, like showing future year design values, projected future year design values, and this shows a component of components to calculate or to derive future year design values. But I'm not gonna go detail here, but I want to highlight this one, two methods. So to calculate projected design values, we use the two different methods. So the first one is we use the 3x3 9-grid cells to determine the cell. And the second method is a modified 3x3 method, and we eliminate all grid cells, which are classified as water cells by law. But we include the water cell if the monitoring site is located in the water cell, we include that water cell. So this shows a spatial pattern of the 2023 projected ozone design values for different platforms. Really tiny. I don't know whether you can see those colors, but in overall, like for all these modeling and they show similar areas where those 2023 projected design values above the ozone net, like 2015 ozone net in orange. And this shows 2023 projected ozone design values comparison between version 1 and version 2.3. And y-axis based on version 2.3 and x-axis based on version 1. And I have this orange circle and indicating those are where those sites are above showing above the 2015 ozone max. And these sites is based on the sites in the OTR region states. So as you can see, our CAMx shows better agreement between those two platforms compared to CMAQ model. And this is using 3x3 method to derive future year design values. And the next is using another method, no water method. So similar pattern, CAMx shows better agreement between those two platforms compared to CMAQ. And comparing to 3x3 method and no water is more consistent between those two platforms. And this shows trends of ozone design values for selected sites shown in this map here. So it's along the I-95 corridor in non-attainment areas in the OTR region. And using 3x3 method and no water method, no water method, this is showing in this inside of the circle and projected 2023. And the others is observed ozone design values. So depending on which the method, some sites, like for example, like Westport in light green, here, yeah, using 3x3 method, and that 2023 projected design values increase compared to 2022 observed preliminary design values. And on the other hand, Westport here, they decrease dramatically. So depending on the method, the design values can be different. Yeah. So this is a summary, and I just stop here and so thank you.
Great, let's have all of our panelists come up. Have a seat. And we have 10 minutes for questions now. And should we? Are they hearing it okay?
Yeah.
So thank you for audience questions.
Everybody.
Yeah.
We can try that out. It'll come up over here.
Okay. Are they hearing it okay online? Okay.
We'll have one of the audience ask a question.
Okay. Great, so yeah, do you have questions?
Yeah, if you can start.
Yes, let's start.
Yeah, there is so much to unpack there that I'm having trouble focusing on even questions. And some of them are kind of the same question. I'm a fire person, I'm at NASA Langley, Amber Soya. So that's typically my focus is fire. I know Westar pretty well. And I've met, but familiar with a lot of the work. So my question is, it's across the board, but also with a focus on Westar, is there something that you could think of that NASA could do in order to help streamline or provide information so that exceptional events would be better, easier? And then, as we go, and that of course applies to California, but then moving to Mike, and what he was Michael with the Geigert, what he was talking about particularly is, you said it was beer's take. I'm like, don't they know that beers, if they're looking at smoke, it appears to be clouds, so it's excluded. So I'm wondering, what is it that they did, and can we reopen an exceptional event? So all of that, I know it ties to all of you, so I got that one. I want to say.
Sure. I'll jump in unless somebody else wants to first.
And maybe can you briefly reiterate the question so they can hear?
Oh,
mine?
yeah. So,
I'm not sure how well they can hear.
Okay.
Sorry.
well, I'll reiterate the question, and if I get it wrong, please. But you're asking what can NASA do to help streamline these exceptional event demonstrations, make them so that they're not quite so maybe complex or difficult to put together. And I think, yeah, for the West, I mentioned even just simply data storage, but the maybe not what NASA can do, but the best thing that could be done was be revised the regional or the exceptional event rule, but that's a different discussion. But I think really a lot of these characterizing what Angie even talked about at first, being able to characterize what is a typical day versus what is an exceptional event day would really be helpful, especially, and Michael might speak to this, he already did in his slides, when EPA says, well, it's got to be at least 5 to 10 parts per billion in the case of ozone above the standard. Sometimes that's a tough threshold, and sometimes an exceptional event might just be 1 part per billion above the standard. But it's still important for that agency to submit something. And so being able to tease out the difference between a typical day and an exceptional day would be very helpful, I think.
And yeah, I would add to that Michael Geigert, the 5 to 10 ppbs was above like a conceptual not event day.
Mm-hmm.
So again, it is tough in areas where you always get ozone anyway in the summer, if you don't model, because we don't really model, we use the NOAA operational model, and they have VOC shut off on that, which is interesting. So you can sort of use that because they don't really do smoke very well. But again, I was thinking what NASA could do. I don't know, maybe the ambassadors or have a website. I thought it'd be nice to have sort of an automated statistical system saying, oh, these are days you might want to consider as an exceptional event. Like I pointed out for Minnesota. I mean, it has to be for a particular model, but I just went to Minnesota and looked at those numbers. I mean, one day was 943 micrograms up there in northern Minnesota with the tribal monitors. Yeah, well, that's pretty bad.
Yeah.
But if you look for the whole summer, there were a lot of days. And if Minnesota wasn't aware of that, I'm sure they were, but it's like, somebody should be working on this. And I don't know if NASA there's a statistical way to say, AOD, of course, it has to be on the ground too, but these are days that might have been affected.
Yeah, I am Daniel. Thank you very much for educating us. I learned a lot. So I'm going to ask my first question. My second question is how do you determine tier 1, 2, and 3? And I looked, Jay also did something like some events you are going to submit, some events you are not. So that's my question. I also have a comment. My comment is it would be nice if you can collectively put together a wish list, like for us to know what you want. Maybe something we can do, something we do not do, but it will be something, a good assignment for the HAQAST team.
something specific. That'd be
I have something
Yeah.
very specific.
interesting.
One of the things that takes us a really long time to do is to find a day that is meteorologically similar to the day of the exceptional event. And so EPA really wants to know, are the inversion layers the same as the meteorological conditions the same? What would the concentrations would have been? And so I think the satellite data is really helpful. But I think making that connection between that conceptual day and the satellite day to be easier to find that satellite data is going to be, can save us a lot of time. And so, and money for that matter of fact. So if there's a way of connecting those where you can easily find that information and click on that satellite data, that'd be extremely helpful.
Yeah, sorry, go ahead.
Well, I
You-
just wanted to also say what I was doing in Fort McMurray, 2016 was tough because most of the summer had smoke. HMS smoke plumes analyzed over the country, at least the eastern US. It's like find a satellite day where there wasn't smoke in the image. That's nearly impossible. So that is quite a challenge.
So just the other question is about tier 1, 2, and 3, and I won't get into that too much, I think, so that we have time for other questions, but basically it's how simple or difficult will the exceptional event demonstration be? If it's a tier 1, it's assumed that it's pretty obvious that there was an exceptional event, and there benchmark some standards within EPA guidance that define whether it's 1, 2, or 3, but yeah, so 1 is presumably the easiest to do. Tier 3 is, that's a PhD project. So if anybody out there is a student and want to do a demonstration. And I would also add to something that would be helpful too. Something else that I didn't add was I think Dan Goldberg is working on this with his NO2 satellites, is characterizing the emissions. So part of what distinguishes between those tiers is being able to say how many emissions came from this event versus how many are typically in the air at any one time, or on a typical day. And so being able to distinguish between those, the better we can distinguish, the easier it is to say, yes, that was an exceptional event day versus no, it wasn't.
Yeah, and I think there's a conversation that we usually have with EPA in the beginning of the process to determine whether or not it's going to be a tier 1, tier 2. And one of the criteria that is usually pretty straightforward is, is this seasonably where you see higher concentrations? And so, for example, I mentioned in my talk where, we don't typically see high emissions of PM 2.5 in the summer. It's usually in the single digits. Well, when you're at, 200 micrograms, that's, pretty straightforward, and a tier 1, tier 2 usually would be sufficient at that point.
I actually have a related question, which is, so I heard some about the technical needs, and I'm wondering, these exceptional event documents are very heavily technical, and I'm wondering if there are challenges in communicating about that to the policymakers, the decision makers, and if there are ways that HAQAST could help in communicating about what the satellite data means, or is that already pretty well covered?
Question. I mean, they're technical. I mean, basically it goes out for public comment, but basically, I mean, EPA is the one that really comments the most on it, and they pretty much understand the technical stuff we're doing. And in the case of Illinois, unfortunately, Northbrook Monitor, it was like the case was, does the trajectory match what they said? Does the Arizona fire make it to Chicago? And basically it didn't, but the other fires did. But EPA did not relent. They didn't say, well, maybe you should go back and look at these other fires. No, they didn't say that. They just said, all this work is for nothing. But I mean, what can HAQAST do to that? Well, I don't know. You almost need a technical support team full time on this, because there's so much smoke. I mean, the western states could probably handle it a little better because they expect it, right? I mean, you have a lot more flag days. We didn't flag any days in Connecticut. I don't know who the East Coast did, but flagging the days is the first step, I guess.
Yeah.
This is one online question.
Yeah, I think.
Oh.
Hello, yes, one online question. Can you please remind us which BL parameterization option is used at CMAQ and CAMx for the study?
Oh, sorry, can you can you say the question again?
Uh,
Sorry.
Can you please remind us which BL parameterization option is used at CMAQ and CAMx for the study?
Boundary layer. Oh.
It's also up behind you.
Boundary condition.
Boundary layer.
Boundary layer.
You mentioned that in the vertical.
Ah,
I know you know it, but
yeah, so I,
I thought it was like maybe related to the mythology model setup.
yeah, like CMAQ, that's based on the meteorology, but CAMx after when we convert to CAMx format, and we used PBL scheme. So like in CAMx, the PBL is slightly different from CMAQ.
Okay, I think we're at time. So I think if you have other questions, please come up and talk to the speakers now, but let's thank our panel again.